Hi and welcome to today's InfoQ hosted webinar with Courier. I'm Eric Costo. I'm a member of the InfoQ editorial board focused on Java and application security. And today we're here to talk about communication patterns of software, which is how apps communicate to backends, how backends communicate to apps, and what happens with pipelines and messages. And when you did in the problem, it is really interesting to see what happens and how different systems can help people get the right message at the right time. Because when we talked about this before, it turns out that there are actually many different definitions of right. There's that browser, when you go to a website, you click the allow notification options. There's one channel for Android, there's a different channel for iOS, and there's a totally different channel for SMS. And as you'd expect, it turns out they're all just a little bit different, even though many of us may think of them just as a message. So our speaker today is Troy Good, the CEO of Courier, who's going to talk about the way that all of these different messages and channels are handled. And what Troy's going to do is to pull back the curtain a little bit to show the different channels and avenues of the conversation within an application and its users, to show us the ways that we can structure our software to communicate effectively with all the different clients that we have connecting to our applications. Now we'll do a live Q&A at the end of this webinar. And please write any questions that you'd like into the question area of the chat, and we'll discuss those at the end. If you'd like, you're welcome to write any questions that you have. They can be questions about the webinar, about something you're working on that's related, or really anything about the topic of application communication. And so now I want to get things started by turning it over to Troy.
Thanks, Eric. Very brief background and introduction for myself. As Eric mentioned, I'm the founder of Courier. But in addition to that, I'm also an engineer by trade. Software engineer, originally a .NET developer, more recently a Node.js developer, and I've spent most of my career building messaging systems, both for marketing automation use cases, but as well as for what we call application to user communication. Eric, just to check in, because it seemed like GoToMeeting flipped me around a bit. Can everybody still see my deck?
Yep, scaling to application to user. The deck is up now.
Great, perfect. All right. So I thought that what would be helpful is to really define what we mean here by application to user. Because if you're building a software product, there's probably a few different ways that you communicate with users and your customers. So one is what we call brand to user. This is often marketing, but there's a few other cases where it's not quite marketing, but it's still ultimately your company, your brand, maybe it's even your product's brand that's communicating to, maybe it's a customer, maybe it's a prospect, maybe it's a partner. So that's one kind of communication. Another kind of communication you have is human to user, right? This is often support, this could be sales, this can sometimes be user to user collaboration. And then underlying all of this, regardless of whether it's brand to user or human to user, are pipes that you send these messages through. Twilio is a very famous and well-known channel and pipe for delivering SMS messages. Obviously, Apple and Google both have their own pipes, if you will, for mobile push. And there are many others for email, for chat, for web push, as Eric mentioned earlier. So those are like different pipes, each of which that are kind of dedicated to a specific medium of communication. And one other category, and the category we're going to focus in on here, is application to user. So these are the kinds of messages that your product is sending, your system is sending, typically triggered from the back end, right? Something has happened. It's usually an event. Some event has occurred, and now you need to alert a customer or a prospect or a teammate. So how do we think about communicating with users from our application? Seems like it should be pretty simple, right? You have your application, an event happens, you pass the event through a pipe, and boom, the user receives that message. Well, it turns out it's actually a bit more complicated than what we think about when we first set out to build this. Quick example, here's just a brief snapshot of one of Slack's notifications, and this is a flowchart of just how they decide whether they're going to send a notification, let alone when they're going to send it, or which channel they're going to use to send it, or what do I do if it fails. There's a lot more complexity here than really what I think most people think about before they set out to actually build it. So realistically, what you're thinking about is really building something with a lot of different moving pieces. We're going to dig into more of this, but you have to be thinking about when you're firing an event, okay, well now, what providers do I want to be able to have that can service that event, right? Basically the channels that I can send through. So Eric mentioned, if you're sending mobile push, for example, well, you need to be thinking about APNS, which is iOS's push notification service, and FCM, which is Google's communication service for Android. If you are sending through email, well, do you have your own SMTP servers, or are you going to use a provider like SendGrid or Mailgun or Mandrill or Postmark? How are you going to log and analyze all of this? Preference management, orchestration. How will you define what does the content of the message look like, and how will you change that as the product needs demand that? So let's kind of dig into this a bit deeper. And just keep in mind, as you do all of this, also, you've got to be thinking about wrapping all of this in a layer of reliability, because this is inherently a bit of a tricky medium where messages sometimes don't get delivered. And you need to also be planning ahead for, well, what do I do in that case? Do I retry things? Do I attempt redelivery on a different channel? There's a lot of different solutions to that, but ultimately your goal here is to solve for your product's needs, solve for your users' needs, and do it in a way that's going to be reliable and maintainable. So the topic here is not just how do I build application to user communication, but how do I scale it? How do I scale that with an event-driven architecture? And what we should think about here are a few things, like basically what do we need to scale? I think obviously there's message volume, right? So we need to scale message volume, but there's actually a few other things that we need to be scaling as well. One of them is the kinds of use cases we can support as a platform, right? You're likely building some kind of service that can be delivered to other teammates and potentially other products within your portfolio if you're a multi-product organization. So as you're building that, you need to think about, how do I scale out the kinds of use cases this platform can support? How do I scale out the message volume that this platform can support? And that's in terms of both throughput as well as kind of latency. There's a few different KPIs that you should be looking for there. How do I scale internal adoption and enablement? The last thing you want to do is invest in building out this infrastructure and then find out that other teams have built out their own infrastructure and you've duplicated effort. So you've really got to make sure that you're building something that supports not just your team, but other teams, and even maybe outside of the engineering organization, teams like the product team or the design team or the marketing team. And whenever we're talking about communication, we're talking about PII, personally identifiable information. So it's very likely that there are some compliance impact that you need to be taking into account, and you need to be thinking about, how do I scale across geographies, for example? Maybe to start with, you only have to worry about one country. Maybe it's the United States. Do you ever plan to send messages in other countries or other states and provinces within that one country? If so, there might be different compliance expectations that you need to meet. So let's start with the use cases side of this, and let's think about, okay, I need to scale out the kinds of use cases this platform can support. Well, how do I do that? The thing about application to user communication is it's unlike human to user communication and brand to user communication. It's event-based. It's happening without a human intervening most of the time. And so what you need to think about is, well, what kinds of events and what kinds of sources of those events do I need to support? I think the easiest one to think about is just a simple backend API call, right? You can think about this as just one part of your application being able to make an API call and purposefully and synchronously kind of trigger a send. So that's really the place that you typically start. After that, you might start to think about, well, wouldn't it be nice if I could, for example, just be tracking all of our user activity and then set up rules to say, when this kind of activity happens, trigger that, without having to go in and instrument a bespoke backend API call. That makes it a lot easier to scale out as you, for example, have a growth engineering team want to quickly experiment on different kinds of communication. You need to think about delays, right? So whether it be from user activity or backend API call, the thing that might be asked of the product or this part of the platform is, hey, send a message later. Well, that becomes its own event source effectively, because if I trigger via backend API call and say, send a message a day from now, well, you're going to queue that up, and a day from now, there's a new source, which is, hey, yesterday, this API call asked me to send, so please send. So you need to be able to accommodate that. Recurring schedules are a tweak on that. Think about, okay, well, if I'm going to maybe send a message every Friday, maybe you can think about a digest that you're sending to users that says, here's the kind of activity that happened over the course of this week. Make sure that you're instrumenting that in a way that you can reach back out from that event source to request additional data. Because if you're setting up the equivalent of a cron job, right, that says run this every Friday at 9 a.m., well, that cron job isn't going to have the latest data. So part of that job will need to be, okay, before I send this message, maybe go out to, let's call it a webhook, for example, or maybe it's a direct query to your database to go fetch other data to incorporate into this message. Bulk and batch. As you start to scale out message volume, you're going to have instances where the product knows it needs to send a lot of messages at the same time. And you can think about this in two ways. One is bulk, which is I need to just send a ton of messages to a ton of different people, and I need to do it in a way that's not going to constrain the throughput of our other messages. So this is what we consider a bulk send scenario, where you want to probably have a separate pipeline to queue all of this up and make sure to obviously go through that quickly, but also do it in a controlled manner so that you can leave capacity in your pipeline for the other kinds of communication you're sending. Batch is kind of the inverse of this, where I'm sending a lot of events, maybe to Troy, and Troy doesn't want to receive a message for each one of those events. So in this case, batch is help me pull down all of these different messages into a single message that goes to Troy. We can think about LinkedIn, for example, doing this pretty well when, if one or two people invite you to join their LinkedIn network today, you'll get one or two emails. If 40 people ask you to join their LinkedIn network today, you're not going to get 40 emails. You'll get one email that just says 40 people asked you to join their LinkedIn network today. Click here to see them. Not all application to user communication is a one-off. Oftentimes you're going to have some kind of sequence. Think about, for example, invitation flows. You want to invite somebody to collaborate on a document with you, or to sign a document, or there's a lot of different invitation flows there. Well, you might send that invitation as a message, but then what if the person you send it to doesn't accept that invitation, right? Oh, the presentation is not appearing. Hold on a second.
Oops, sorry, I meant that in the background chat. I was trying to get that over to our staff from
Okay.
the chat here. We'll figure out what's going on here.
Great. Okay. Great. Okay. Well, so sequences are, you think about an additional event source is one message causing a subsequent message to potentially fire in the future. So I send that invitation to Troy and say, hey, Troy, come join me to modify this document with me. Now there's a kind of an expected activity, which is that Troy is going to click through, he's going to join that document, maybe he's going to sign it, whatever the kind of conversion event you're looking for is here. If that doesn't occur, now you've got a new event source, which is kind of somewhat related to user activity, but it's separate because it's contextual user activity tied into a prior message. And so you've got, for example, send the invite, and then after a day, if Troy still hasn't performed that activity, send a reminder. Maybe you have multiple reminders, and you also need to think about, in the case of sequences, how to cancel those sequences, because let's say I've got a string of messages I want to send to Troy, which includes multiple reminders. At some point, if Troy actually does perform the activity, you want to ensure that those future messages don't get sent. And lastly, while the vast majority of the time, application to user communication is triggered programmatically by these different event sources, you do need to think about ways to trigger them manually. And the reason why is sometimes mistakes happen, right? Sometimes there's a bug. Maybe you have the template has a typo in it that's critical. We've all seen that kind of. I think HBO Max sent out that huge blast of emails where they had the variable was not being filled. Sometimes you need to resend. Sometimes you need to be able to send out a slightly customized message. So make sure that you're instrumenting your infrastructure in a way where, if you need to, you can manually trigger these sends as well. And so this is once you've got these events firing, right? And I call this an internal event source. Now, what we recommend is flowing that event through what we call a delivery pipeline, right? And this is the way that at least we structure it and the way that we would recommend thinking about structuring these delivery pipelines. The first thing that we would recommend doing is kind of having a prepare step. So this event happens, it comes in, but you are very likely going to want to be able to kind of attach additional context to this event because the event's probably going to be lightweight and you might want to go fetch additional data. An example of fetching additional data might be the user's preferences or information about the account, the customer account. Maybe you want to know what pricing plan that customer is on. You don't necessarily want to include this in all of the events just because that makes it kind of hard to maintain and include everywhere. So you want to have a step at the beginning where you can go out and fetch this additional data. You can also do things to kind of crunch it all down. And for example, you might want to pre-calculate the template that you're going to generate that's going to be included in the render step later. Once you've kind of done your upfront setup of this message in response to the event, you're going to want to on-queue this, and we do recommend either using queues or event streams. We've migrated from queues to predominantly using event streams at this point. We'll talk a little bit more about that later in the scaling the message volume section. But the very next thing is having a step in your delivery pipeline that thinks about routing. Routing is really determining whether to send the message, what channel to send it on, right? Is this going to email or is this going to mobile push or is this going to SMS? Within a channel, what pipe or provider is it going to use? If it's going out via mobile push, does this go to iOS or to Android or to both? And taking into account user preferences as well. So the user might have some preferences where they say, you know what, please do this instead. Render, which is take that event and transform it into the ultimate content that is going to be delivered downstream. This does vary by channel and by provider. So you wouldn't send the same content to, say, an SMS as you would to email, right? Email is both a different technical format, it's using HTML, but also the content is richer and longer. You're going to be more concise and plain text with SMS. The last core part of this delivery pipeline is the actual send step. And this is one where, okay, this is where you're going to make the ultimate downstream API call to, if you're sending an email, maybe your SMTP provider or to the SendGrid API. If you're sending an SMS, maybe this goes to the Twilio API, et cetera, et cetera. And you want to instrument this with sufficient logging so you can understand what's happening for each of these different kinds of messages. And also you need to be able to handle failure here. And this is where the reliability really kicks in. And you need to think about, okay, well, what do I want to do if a send fails? Do I want to just retry it immediately? Sometimes that's okay. Do I want to pass it back through our routing infrastructure, which is what we recommend, so that it can, the routing infrastructure can look at it and say, maybe it wants to reattempt on a different delivery provider, or maybe even a different channel, or maybe even say, we're not going to attempt this at all. And then somewhat outside of this process, you have other external events that are coming in. For example, delivery tracking events that will come, or open events or click-through events that will come through the different channels and providers. And that needs to also flow back into your routing infrastructure so that your routing infrastructure can know, okay, the user did not click this, so let's reattempt delivery on a different channel. So let's dig into each of these in a little bit more detail. So when I'm thinking about building out the routing part of my delivery pipeline, here are the things that we would recommend that you think about. The first is what I think of as just the user's channel availability. If you don't have the user's phone number, SMS is just not going to be an option, right? If they haven't clicked the little allow button in Google Chrome that says allow me to, let me send notifications here, web push is not going to be an option. Within a channel, you've got provider availability as well. So imagine mobile push is one of the channels that you're supporting for your user. Well, now you need to differentiate between, do I have an Android FCM push token for the user, or do I have an iOS APNS push token for the user? Same thing, maybe it is SMS, but you want to think about, well, is the region that their phone number belongs to, is it supported by my SMS provider? And if not, do I potentially use a different SMS provider, or do I not have one that covers that region, in which case you might want to consider a different channel? User preferences, I already mentioned. You're likely going to want to have some ability for your user to customize which notifications they receive, when they might want to receive them. For example, you might want to allow people to set an away mode or vacation mode. You want to likely allow them to configure which channels they do and don't want to receive notifications on. We often see that as kind of a checkbox grid, right, of the different kinds of notifications I want as the vertical axis, and the horizontal axis being which channels I want to receive that notification on. Routing is also where you're going to think about your provider resiliency, right? So I already mentioned if let's say I'm making a call to one of my downstream providers and that call times out, that API doesn't respond in the time that I've allotted to it. Well, what should I do? Should I retry that, or should I, on the same provider, should I try a different provider? Should I go to a different channel? In some cases, the answer is really clear. If I attempt to send to a phone number and that phone number no longer is in service, then I should probably reattempt on a different channel, because reattempting to the same phone number is unlikely to result in a success. Likewise, if I'm sending an email and the email service API tells me that my API key is bad, well, I should log that and make sure that somebody from my ops team is aware of that so we can fix it. But also, it's not worth retrying because that API key is very unlikely to suddenly be good. So in that case, I should be trying a different provider. That timeout scenario, though, is trickier. Sometimes you'll see that there will be performance challenges for the downstream provider, so it may be worth retrying, but you might want to put some limits there on how many times you want to retry, or a maximum time that you want to retry. Engagement optimization, this is what I was talking about earlier around, think about things like, based upon users' behavior, do they typically engage better? Do they click on your emails more, or do they click on those push notifications more? That might influence which channels you want to use for each given user, if, for example, they're allowing you to send to multiple channels. And lastly, price optimization matters a lot at scale. So if you're operating in the millions of messages a month, you should be thinking about price optimization, especially for expensive channels like SMS, where the difference between vendors can vary, for example, by geography. Twilio is generally speaking the SMS vendor we would recommend if you're sending SMS in the United States, but I actually quite like MessageBird if you're sending SMS predominantly in Europe. What happens if you're sending messages to users across the world? Well, you might want to start to look at the price per geography for those users, and potentially even routes to different vendors depending on the region and locale of the user that you're sending to. So as you're going through routing and then you ultimately go to the rendering step, there are going to be different formats that you need to accommodate. So this is going to be dictated by which channels you want to support. So if you're sending emails, for example, well, ultimately you're going to be rendering your messages to either plain text or HTML. You're probably going to want to choose HTML, even if you do have a plain text fallback, because that's going to allow you to have hyperlinks, right? If you have just pure plain text, obviously the user can copy paste. Sometimes their email client will make that clickable, but for the best user experience, and also frankly to allow you to incorporate the best tracking so you can know the effectiveness of your messaging, HTML is going to be what you want to send. If you don't know, email HTML is kind of very old school. You're basically implementing not the latest and greatest React components. You're implementing HTML as it was in 2003 so that it can work well across a wide variety of email clients. There are tools like MJML that can make this easier, but it's not fun, and you'll definitely want to think about testing this across various clients. If you're sending to SMS or providers like Push, you're really thinking about either plain text or some slightly rich text, depending on the specifics of that channel. Sometimes you can do bold and italics, but for most of these channels, we're really looking at pure plain text. So you'll want to think about, okay, well, if you're sending to multiple channels, how do you specify these templates separately so that you can easily hop in and say, okay, well, this is what, when this message goes out via email, this is what I want the content to look like. And that might have images, it might have coloring and rich graphics and rich formatting. Here's what that same notification should look like if it goes out over SMS. Other channels have even more bespoke formats. Slack has something called BlockKit. It's a JSON-based format Microsoft Teams, if you're sending messages to Microsoft Teams, has its own card JSON syntax. So you'll want to look at the different channels that you're planning to support and understand what are the formatting, what's the expected format of the messages you're going to send through that, and then think about, okay, how am I going to store and specify these templates, maybe in different folders in your Git repository. Maybe you have a UI that lets your product managers or designers quickly make changes here. Whatever it might be, you've got to think about, okay, how am I going to do that in a way that will support these different channels? You'll also want to be thinking about, how do I test this, right? So there are some great services for testing emails. We recommend a service called Litmus, litmus.com, where you can send that email to that service and then quickly look at it across a variety of clients, so you don't have to sign up for your own Hotmail account and Gmail account and install 5 different versions of Outlook. Litmus will take care of that for you. But you'll want to think about, how do you do something similar for, say, SMS, for push, for Slack or Teams, whatever channels you're supporting. We recommend thinking about empowering your non-engineers. Typically, this is project or product managers and designers. My experience is it's very rarely the engineer who wants to make a change to the template or recommends, hey, we should change this text. It's usually coming externally. And this is the kind of work that is hard to make it into a sprint. So the more you can do to enable your non-engineering teammates to make those changes themselves, or make it easy for your engineering team to make those changes on behalf of them quickly without making it a large ticket, really pays dividends in your ability to scale out the amount of effort required to maintain this. And lastly, as part of the render step, you also do need to be baking in tracking, right? And so typically for email, this is done via redirect links and tracking pixels. And this is what will tell you whether a user opened an email, whether a user clicked through the email. You typically have a different solution for each of the channels. So for example, SMS, there is no equivalent of opening it, but you may want to still render the links that you're passing through with a dynamic URL so that you can do click-through tracking. All of the kind of downstream activity tracking that you want to incorporate really has to be included in here in this render step, since it typically impacts the content of the message that you're sending. Okay, and so now I've received a message, I've routed it to the right channel, I've rendered it to the right format for that channel, and now I need to actually send it. So a few kind of lessons learned from us here is, when we started out building what we do for a living, we started just leveraging the downstream providers' SDKs, and that seems like the sensible thing to do. But unfortunately, what we found is that it's often really kind of hard to debug the problems that you'll run into. And so, for example, it's if you're sending at high scale, if you're scaling this out, there could be, for example, a memory leak in the provider's SDK. How do you validate that? We've found that to be challenging. There can be churn in the SDK itself that's separate from the API. Typically, most of these providers offer stable, backwards compatible APIs. So the nice thing is you can program directly against the API, implementing a direct, for example, REST API call, and that's unlikely to break. We actually find that it's more likely that the SDK will break, and they typically, I've seen that they're not as well maintained as one would hope. So our kind of hard-earned lesson is we now only implement directly against the core API without putting the provider's SDK in the middle. If you're planning to operate at scale, I would recommend at least considering that, especially if you're going to be implementing multiple providers. If it was just one, maybe you could get away with it. But if you're going to be maintaining a bunch of these, I highly recommend just pick a HTTP library that you're happy with and work directly against the provider's SDK API rather than their SDK. These different providers are going to have different communication methodologies. Typically, it's going to be REST is the core transport mechanism, so HTTP REST. But different providers and different channels are going to have different expectations of what happens when they actually receive that message. So, for example, a Slack notification, if you trigger a Slack notification via their API, it's essentially synchronous. You can make that call. It'll tell you that it sent the message, and you can have it up side by side, and you'll make the API call, and you'll see the message and get back a response that says, yes, I delivered it to Troy. That's easy, that's great. But most providers, and especially older providers, for example, email and SMS, older channels, they don't give you that kind of synchronous state update. What they do is they give you essentially a 2XX saying, I received this, I acknowledge that you've asked me to deliver this message, but you're not going to know whether it was actually delivered. You actually have to then go and implement, for example, either a polling mechanism or webhooks to receive the actual delivery event. We'll talk a bit about that in a second as well. But either way, you're going to have these different channels and different providers that are going to have different state management mechanisms. And so you need to be thinking about synchronous versus asynchronous status responses. And either way, we strongly recommend normalizing these responses so that you can ingest this into your monitoring and observability platform and essentially compare apples to apples, right? You want to make sure that as these things are happening, you're able to quickly and easily diagnose when there's errors and when there's timeouts and when there's throttles without having to look at each of these events and providers separately. And once again, thinking about that retry methodology, right? We already talked about this a bit. A couple other things to consider here at this send step is timeouts, right? So think about what's the maximum duration that you're willing to retry against a given provider. What's the maximum duration you're willing to do this at the channel level, right? So maybe you're willing to try push for 10 minutes, and if that doesn't work, you want to send an email instead. And lastly, think about timeouts at the message level. So let's say, for example, you only are sending to a single channel. You only have a single channel and a single provider. That's perfectly reasonable. You might have messages that you want to retry. You absolutely want to have resiliency here, but there's probably a maximum that you want to incorporate. A great canonical example for this is two-factor authentication. Let's say you're sending out a two-factor authentication message via SMS, and that two-factor authentication code is only valid for, let's call it 15 minutes. And now let's say you're having a delivery failure with your SMS vendor. Well, if that recovers 20 minutes after you attempted this send, that code that you generated at the front is no longer valid, right? So you should not reattempt that delivery of that same message past the expiration there. So, and it's also like, imagine, letting somebody know that the sporting event's about to start the day after the sporting event happened, right? So think about like, what is the maximum duration that you're willing to retry these messages? Once you've sent it, as I mentioned, a lot of vendors, a lot of channels are fundamentally asynchronous in terms of status. So you're going to look at your vendors and decide, do they support webhooks? If so, we recommend supporting a webhook endpoint on your side to receive these status messages. Some providers do not, and in that case, you're going to have to set up a polling infrastructure where you're going to decide on a cadence in which you can go ping their API to fetch that status. As I mentioned, you want to normalize these responses and normalize these statuses. So different providers, different channels are going to return different statuses to you. Think about your kind of own mapping, your own categorization of these statuses, so you can, again, in your analytics and observability side, compare apples to apples. You want to be able to, if somebody tapping on a mobile push notification from a product perspective is more or less, it's the same as clicking on a link in an email, right? But they're going to look like different events, and you should probably consider saying, hey, I want to have a layer on my side that says these are the same thing, so that when you're looking at it in your data warehouse, for example, you can say, hey, how many people clicked on this notification regardless of which channel it went through. And last thing is, this gets pretty tricky at the status checking side of things, because you're basically now in the asynchronous part of this flow. How do you correlate all this together to say this is all part of the same message and all part of the same user? So if I'm sending to Troy's phone number, and in a separate occurrence, I'm sending to Troy's email address, and Troy clicks on the link in this SMS, Troy clicks on the link in this email, you want to be able to have a way to correlate all that all together and say, well, these were both two instances of the same message. Both of these are the same user. If you just look at the phone number, just look at the email address, that can be hard. So make sure you have some sort of correlation ID to tie all of this together. And we're finally at the actual volume scaling part. This is the part where it really comes down to how much message volume you're planning for. There's a lot of other parts of scaling that we just addressed in terms of the complexity that you need to scale for, right? The use case complexity. spikes and valleys happen in messaging, right? So, it's interesting because kind of regardless of what your overall aggregate message volume is, you really need to be thinking about what kind of maximum throughput do I need to handle. We have a customer who sends 98% of their volume in any given week in a 20-minute period every Monday. And it's just the nature of their use case that they have this huge spike, and then it's basically a valley for the rest of the week. So for them, they need to think about how to accommodate that spike. Not how do I take the amount of volume I'm going to send on any given month and divide it by 30, divide it by 24, divide it by 60, and there's our per minute throughput. That really wouldn't work for their use case, but it might work for yours. So think about what are the spikes that you need to be able to support, and then you're going to have to architecturally plan to support that spike. We started off using a queue-based delivery pipeline. We have primarily moved over to data streams. We are hosted on Amazon. We use AWS Kinesis, but there's a number of other options here that you could be looking at. We like that for the ability to easily replay things. Pretty easy to attach additional handlers so you can do a fan out, for example. We've just found it's a better fit for this kind of use case than just the traditional queuing infrastructure. We think serverless is a great fit. I think one of the talks I'm giving later this year is why Courier uses serverless and you shouldn't. It's a pretty early technology that I wouldn't recommend for, say, a traditional CRUD application. But for this kind of message processing and pipelines, serverless is a fantastic fit. Makes it really easy to scale up to meet those spikes without having to maintain the infrastructure during the valleys. You want to optimize each step of that send pipeline because each of them needs to happen very quickly, not only because that's going to reduce latency, but because especially if you're using serverless, that's going to directly impact your costs. So the less work that happens in each of those steps, the more effective this pipeline is going to be, both in terms of performance and in terms of price. So we do recommend using key value data storage, whether that be in a relational database or whether that be in a NoSQL database like Dynamo, which is what we use. Minimize the index hits or maximize the index hits and minimize things like queries, right? Try to retrieve only a single record at a time rather than having to get back a huge set of data and then scan through it. You want to really optimize and do the least amount of work per step in that pipeline. As you're processing through that pipeline, the nature of message sending in many cases, but not all cases, is you might have large files that need to be associated with this. And I think the clearest example of this would be in emails if the email has an attachment. You need to make sure that you're thinking about how to store that message attachment in a way that's not itself floating through the pipeline, because you're going to really create too large of a message to handle in a performant way. What you really want to be thinking about is making sure that you can take any large parts of these, and it could be the attachment, it's sometimes actually the message body, and you want to offload that into separate file storage that can then be referenced by the message as it passes through the pipeline and be pulled in at the steps where it needs to be. So for example, you're going to pull this in at the send, an attachment is going to be pulled in at the send step so that it can be base64 encoded and streamed across the API to the downstream provider. But you wouldn't need to actually have access to that full attachment in the routing step usually. And kind of last thing here is really closely monitor cost, latency, and throughput. Just yesterday, we had a customer whose volume spiked by over 4,000%. That's something that happens in messaging. And in our case, we had to reach out to them to verify that it wasn't a mistake, because sometimes it is a mistake. Sometimes it's a runaway loop, right? There's all sorts of things that can spike it. Now, in their case, that was expected volume, which was great. But you really want to make sure that you're getting proactive alerts to know when either you're sending way more than you would expect or way less than you would expect. Not only is this going to impact your price, your cost, but it's also potentially a signal that something's going wrong, right? We saw a customer at one point, they shipped a change, and all of a sudden, all of their notifications turned off, right? They were no longer sending messaging, and that included their login and password reset notifications. So we let them know, and they were luckily then able to go and recover and fix it. But if you didn't have that monitoring observability in place, and all of a sudden you ship some unrelated change, but for some reason it breaks your login mechanism because you're no longer getting those magic login emails or those password resets or the two-factor authentications, well, you want to make sure that you're aware of that as quickly as possible. And if you do go down the serverless path, beware of cold starts. This is a pretty well-tread topic on the Lambda side, but you're going to see, again, you're unlikely to see constant peanut butter spread volume. You're more likely to see spikes and valleys. So when those spikes hit, you want to make sure latency is small, and so you need to make sure that you're keeping things warm so that it's ready to send immediately. I believe the last topic here is compliance. I'm not going to spend too much time on this, but this is a pretty complex area. It's going to vary heavily based upon your business. So this is one where I would recommend spending time with your legal and operations team and understand what are the compliance obligations that your business has when dealing with personally identifiable information. We're based in California, so CCPA is something that we certainly have to deal with. By nature of our business, we have customers all around the world, so we also have to deal with basically everything. But your business might, for example, be predominantly doing business in Europe, in which case you're going to be needing to think about GDPR. PIPEDA is the equivalent in Canada. There's a few other state-based instances inside the United States, potentially a national one coming in the future as well. There's also channel level compliance. So if you're sending email, you need to make sure that you're compliant with the CAN-SPAM Act if you're doing so in the United States. If you're sending SMS from the United States, you need to be make sure you're compliant with TCPA. And your business might also have internal compliance standards that you need to meet, such as SOC 2, ISO 27001, or if you're dealing with financial data, PCI DSS, if you're dealing with healthcare related data, HIPAA, etc. There's many other standards here that might be more relevant to your particular industry. So make sure you're spending time with the business to understand what the requirements are. There's a lot here. It's pretty expensive. If you're doing this at scale, which is really the topic of the discussion, plan to invest heavily. So when we spend a lot of time with the largest sending technology companies, and it's not uncommon to have teams of dozens of people that this is all they do for a living. If you're just getting started, that's not going to be true. You can get away with having one or two people, but it's going to scale in complexity over time as both use case complexity and volume increases. This is, when we look at, for example, LinkedIn, they have over 50 engineers working on their communication infrastructure, over 20 at Uber, etc. It's a larger problem than what you might be thinking before you set out there. Obviously, the pitch for us here is we love to remove that complexity for our customers and act as this pipeline. But ultimately, you don't need Courier. You can build this yourself. And we're always happy to talk to folks who are building, who maybe have already built. We'd love to help if that's something where you'd love to learn more about how we handle this, how we kind of pull together all of the different destinations that our customers send to and make it easier and more maintainable for their engineering and product teams, and ultimately create a better user experience for their customers. And I think we'll go to the Q&A.
All right, sounds really good. So we had a couple of questions that came in here. Some of them were about the presentation. To answer the questions, yes, the presentations will become available. I think there's a recording that gets emailed out to everybody also. So you'll be able to watch this at home at your leisure if you want. All right. So the first question that came in here is, my application emails users per event, and we've had some people complain that this is too many. So how can I update to trap these and change the message?
Yeah, absolutely. So what I would recommend here, and this is what we call batching, right? And so what we recommend here is introducing a service in between the code points that are sending the email. Don't have the different parts of your code that would send a message, send that message out directly to the email service provider. Instead, add some sort of notification service that those same endpoints can call instead. And that notification service is what's then going to be responsible for firing the call to the email. Once you have that, now all of a sudden you can start to add logic in here into that notification service. And this is where you would do the batching. So The use case, kind of like the actual implementation, will vary by your use case. But what I would look at as a starting point is what we call the debounce method, which is you can set up, for example, a trap where these events come in. You want to queue those events up with a release window. So, for example, you want to say, all right, from the first time that an event for this user comes in, I'm going to then wait up to 30 minutes for any additional events. And then every time a new event comes in, let's add 10 more minutes to the clock up to a maximum duration of 2 hours. This actually comes from the hardware space. So Eric, you might be familiar with debouncing from hardware and IoT. You can do the exact same thing with messaging. So introduce that intelligence layer in between where your application is triggering the event and where the code is actually passing that downstream to the email provider.
Okay, cool. And I imagine LinkedIn has got to be really good at that. Number one, because you had them
That's right.
spending a lot of money on communications. Number two, they send me messages like almost nonstop, and they do seem to batch and kind of shrink
They
down.
do. They do.
All right.
They've actually, yeah, they've got a platform called Air Traffic Controller, which is essentially their internal version of notification infrastructure. And they've actually written quite a bit about that. And so that's, if you're interested in learning more, I definitely would recommend searching for LinkedIn Air Traffic Controller notifications, and you'll be able to see a little bit more about how they do it.
Okay, that's actually addresses the next one that came in that said, thanks for the amazing presentation. I have a monolithic REST API which sends emails and notifications. For now, to reduce the billing, I create a separate thread for sending these. I want to shift this to an event-based. Where should I start? Any book you recommend?
On a book, interesting.
I think the book is more in terms of what to look at. So since you mentioned LinkedIn has a lot with air traffic control, that probably has some good material there.
Yeah, absolutely. I would definitely recommend checking out LinkedIn's right up on Air Traffic Controller. Make sure to tag on notifications, Air Traffic Controller notifications. Otherwise, you're just going to see job postings to be an air traffic controller. And Airbnb has a platform called Omni, which is their internal version of this, that they've written up quite a bit about as well. So those two would be where I would start to learn more about that.
All right, I'm going to type this answer also because it involves a search. LinkedIn Air Traffic Controller, Airbnb, and what was the name of the Airbnb one?
Omni, OMNI.
All right, cool. I'm going to send to all, but it looks like he already found the, air traffic member first notifications at LinkedIn.
That's
awesome.
Right.
That's probably going to be a good post. I'm going to copy that one down to look at it. All right. What are some good ways to handle the idea of different sized messages? If we text someone, the message is small. In email, it's larger. How can we ensure the right info gets across regardless of the channel?
Yeah, so this is where you need to be thinking about templates as effectively on a per channel basis, right? So you want to have fundamentally a separate template for email and a separate template for SMS. In an ideal world, you could share content between them. That's something that we enable, but you don't really have to have that. So for example, you could have a handlebars template stored in your Git repo for email and a plain text template stored in your repo for SMS. But you are fundamentally going to have essentially two different templates here. I don't think there's really any way around that, just because of the different, formatting aside, the different content expectations for these different channels, as well as if you even think about chat, for example, even though chat is really the same length, more or less, as SMS usually, you would typically want to be more conversational with a chat-driven message. So even there, the content would be different between what you send over SMS versus chat. So all of these channels, you need to really basically have a way to have different templates for each of the channels per notification.
All right. So the next question actually seems relatively related to the templates, which is where is the best place to put the different presentation layer? Should my app manage the SMS or Slack JSON, or should the part that handles that be like a microservice in the pipe?
So I recommend co-locating this with the overall notification service, right? And the reason why, and there are some challenges here, right? Because I think that, let's imagine you have a larger product that has multiple product feature teams and then one shared product infrastructure team. That's where we typically see this question really popping up. And so let's just imagine a world where I have 3 different feature teams that need to send notifications potentially across multiple channels. And then I've got a infrastructure platform team that's maintaining this core notification service. Where does the presentation layer live? What I would recommend is actually co-locating that presentation layer inside of the notification service, and then making sure that you're creating a way to allow the feature teams to come modify that presentation layer part. And so maybe that's a separate repo, maybe it's not, maybe you're providing a tool for them to be able to update this. But regardless, I think what you want to be doing is making sure that the feature teams are really just publishing events to the notification service and not dictating the presentation layer from the feature side of things. And that's by co-locating all of that in the notification service, you're going to be a lot more nimble and able to actually iterate and, for example, add a new channel quickly. Whereas if you co-locate that inside of the feature side of things, anytime you want to expand or change the capabilities of your notification service, it's going to be a nightmare because you're going to be going all over the place to actually do that.
Got it. So that's probably what you were talking about back in the beginning of like enable the business user to be able to manage that content and material. Okay, cool.
Yeah, and sometimes that business user is just another engineer on a different team.
Totally fine. All right, so can you talk a bit more about messages from the user, like if they hit reply?
Yep, absolutely. So the main way that we think about that is we call this inbound normalization. So similar to a user having activity like an open or a click, a reply is essentially the same kind of thing. It's just a different kind of activity. But what I talked about around asynchronous tracking and normalization still applies here. So different vendors and different channels are going to have different capabilities here. So let's say that you're talking about SMS. And so SMS, somebody just types back to you and presses send. Well, what you probably are going to do is your vendor, let's say you're using Twilio, will let you set up a webhook destination. So you would host an API endpoint on your side, and you would configure Twilio to say, call this API endpoint whenever the user responds to this text message. The next part, as soon as you receive that webhook, that part's honestly pretty easy to set up. Okay, boom. Now all of a sudden somebody replies and some code on your server now executes in response to that because that webhook got called. The tricky bit is now making sure you're able to correlate that inbound message with the outbound message that just went out, right? Because let's say that my application is asking you to approve Eric's PTO request, and the recipient replies back, sure, or yes. Well, you've got to figure out how to normalize the different kinds of responses because you're now talking about like arbitrary plain text. So think about that. But also, how do I know which PTO request was just approved, right? Let's say I sent out 3 PTO requests and somebody replied, yes, no, no. Well, how do I know what to map those to? So you're going to want to make sure you have correlation IDs included here and a way to correlate all of this activity back, not only to the correct user, but also to the correct message that it was sent out from.
Oh, okay, yeah. So you need to be able to fix and associate that the response is to a particular message, not just random things coming in.
That's right. That's right. And also one other thing on this is think about normalizing across channels. Assuming you support, for example, email and SMS, well, both of those the user can reply to. And if the user replies to email, their response can actually be an HTML response. So you might need to be thinking about how do I normalize the inbound format of these responses so that I can treat a yes coming in from SMS as the same as a yes coming in from email that might be bolded and red.
All right, so it looks like there's one more question here, which says, what are the different steps of sending a message? You said to break out the message body, so what happens there?
So the send step is ideally pretty lightweight, right? By the time you get to the send step, you already have an event. The event kind of payload that's coming through should already be telling you who it's going to, right? What the correct address for that user is. And what I mean by that is if it's, this is gonna be channel specific. So if this message has been routed to email, you wanna know that it's going to which email address. If it's going to SMS, you wanna know which phone number. So you wanna know like the correlation ID for it, which channel it's going to, what the address for that channel is for this given user. And then you're going to, from the render side, you're gonna have passed in what is the actual rendered content for this. The send step is then basically just aggregating all of the data that you processed in the prior steps, and now you're executing the API call against the downstream service provider. So it doesn't really do a lot of logic in that send step. It's really just pulling it all together, actually making the call, and then the logic is really the normalization of, okay, when the response comes back, or maybe a response doesn't come back, what do I do next?
Okay, cool. All right, it looks like those were the end of the questions. So if anyone else has any question that they want to ask real quick, we can answer it. Otherwise, Troy, any final things that you want to mention to wrap up the presentation on app communication?
No, other than I geek out on this stuff all the time. Like I mentioned at the top of the time, I'm an engineer myself. Always love to talk about this. So if you're building, you know, app to user communication, I would love to hear more about how you're building it. If you have any questions, feel free to reach out to me. My email address there is at the bottom. You can also check out what we do at Courier.com. Would love to hear your thoughts and spend more time talking to folks building notification infrastructure.
Sounds great. All right. Thank you very much, everyone, for attending today's webinar, and we'll send you over a copy of the slides and the recording. Have a nice day.
Thank you, Eric.